Well, on to our new material for today. And with our new material, I want to actually start with going over some slides from the older material, because in order to understand what we're going to cover today with box plots, or also known as box and whisker plots, you need to remember about quartiles and minimums and maximums and so on. So let's just quickly review what we did already. We did these exact slides last week. The quartiles of a data set divide the data into four portions. That's why we call them quartiles, like four quarters in a whole. First, second, third, and fourth quarters. Now the middle quartile, or the second one, is the score that's in the middle, and we already call that the median. Now the lower quartile, or the first quartile, you can call it either one, Q1, divides the lowest fourth of data set from the upper 3/4 of data set. The upper one is called the third quartile, or Q3. Okay, it's the median of the upper half of the data set. The lower quartile is the median of the lower set. And then we have this thing we call the 5-number summary, and it goes like this: the minimum score, which is the lowest, the maximum score, which is the highest, the median, which is the one in the middle. Now, for this lower half of numbers, take the median of the lower half. That's your first quartile. For the upper half of numbers, take the median of the upper half. That is your third quartile. So here's a set of 5 numbers. Obviously, the minimum is 72. The maximum is 78. See them there? Minimum 72, max 78. Obviously, the middle number is 76. So that's your median right here. Now, I take the numbers below the median, and I find the median of the numbers below the median. That was 72.5. So that's my first quartile. And then I find the median of the numbers in the upper section of numbers, the upper half, and the median of that is 77. So there's my third quartile. So the lower quartile is the median of the lower half. The upper quartile is the median of the upper half. Here's some more numbers to look at. The smallest one is 67, so there's your minimum. The highest is 84. 76 is right smack in the middle, known as the median. The lower half is 67 and 72. That's an even number of numbers, so we take the middle of those even numbers, which is 69.5. And likewise, the middle of the upper half of numbers. That gives me the third quartile of 80. So the first quartile is 69.5. Third or upper quartile is 80. Now, you find the minimum, first quartile, median, and third quartile, and maximum of this set of numbers. Do stop and start. Okay, so they're right away very easy to identify the minimum, the maximum, and the median, the one in the middle. Notice there are 3 numbers below the median and 3 above. Now, that gives me the lower set of 3 and the upper set of 3. Remember, the median divides it into 2 halves. Those are, above the blue lines, those are the 2 halves. Now I need to find the median of each of those groups of 3. Well, on the lower group, the median, being the one in the middle, is 11, and in the upper group, it's the 20. And those constitute the first and third quartiles, which I can then graph. And this is the new stuff for today. So everything I've reviewed so far, this is the newer material, and it basically takes this information and marks it on a graph, a number line, with a very specific way of doing it. This is the way you do it, okay? I actually forgot something here. The lower quartile down here at 8, the upper quartile, the minimum down here at 8, the maximum up here at 25. The lower quartile was 11, so I make a mark there. Pretend you don't even see the lines. And then I make a mark at the upper quartile, which is 20. And then I make a mark at the median, which is 17. And then I make a box around this middle set of data. What I forgot to do was draw a line down the middle here of the median. There should be a line added right down the middle of the median. There's going to be plenty of other examples where I have that so you can see it. Train's going by the house, that's why you hear the dogs bark. Now, this is called a box plot, or back in the day, we used to call it a box and whisker plot. Okay? Now, here's one drawn out for you. The minimum goes all the way down this end. The first quartile here in blue. The red is the median. Remember I said I left that line out? There's a picture of the line. And here in the orangey tan or whatever, the pumpkin color, that's the third quartile, Ziva Hush. And the maximum is over here. We call the box the piece in the middle, and nowadays they've taken to condensing it to just calling it a box plot. But in the days past, we used to call them box and whisker plots. So you may hear that term box and whisker plot. One last thing to consider is what we call the interquartile range. You know the range is the highest minus the lowest. The interquartile range is the highest quartile, namely the third quartile, minus the lowest quartile, namely the first quartile. So let's now take a look at this and figure these things out. Well, the minimum is clearly 2. It's above the 2. You can see that mark right there. Next up, what's the first quartile? Well, the first quartile is 4. Now, obviously, we want to get to the point where we don't mark the diagram with minimum first quartile. Median is 6. There it is. The third quartile is 8. And the maximum is 10. A couple of things to notice here. Notice that you are not drawing it on the graph. It's above the graph that you're drawing it. Notice that line through the middle of the median there. And the next question I have for you is, what is the interquartile range? Well, the interquartile range is 4 because the third quartile is 8, the first quartile is 4, and for range you subtract, so 8 minus 4 is 4. What if I said, what's the range as a whole? I didn't mark this down, but the thought occurs to me. What if I said, what's the range of this data? Well, the range would work out to be 8, right? Because the maximum is 10 and the minimum is 2, so 10 minus 2 is 8. Okay, so here is a 6th grade math test. If you can mark that 5-number summary, minimum, first quartile, median, third quartile, and maximum, go ahead. So the minimum score, and I'm approximate here, it looks to me like a 68. Okay, maybe you would have had a 67 or a 69, but it should be right around a 68. The third quartile would be right here, and I put down a 78 for that one. The median, that's right on mark. That's an 85. The third quartile looks to me like a 93, and the maximum looks like a 99. Could be a 98, could be a 99. That's why we're not going to go crazy over this. What's the interquartile range? Okay, that would be 93 minus 78, which is 15, based on my numbers. Okay, what would be the range overall? Well, 99, the maximum, minus the minimum, 68. 99 minus 68 is 31. Again, I didn't have that marked down. It's important to know about box plots or box and whisker plots because you often see data, or fairly often you see data summarized in a box and whisker plot, okay? If you're teaching really well, you want this near the upper end of the graph like it is here. And you want to keep this whisker on the left here a little short so you don't have anybody down the low end there. And then this box should be packed with data. That means all the kids are doing pretty well. When the box is really long and spread out, it's not so good. Okay, so what we're looking for here is, here's a salesperson Angela and salesperson Carl, their box and whisker plot. Let's get that 5-number summary going on here. So we have Angela. Her minimum is about a 1, right? Because here's Angela always over here. You might have thought it was a 0. A little tough to tell. First quartile, I had it down for being about 18. Median, I thought it was about 28. Third quartile, I had 41. Maybe it's more like 42. That's why, like, if this was a multiple choice, I would not give you 40, 41, 42, 43. I'd give you more like 37, 41, 45, 50, so that they would be spread out enough that you could tell which is the only reasonable guess. And the maximum I have down was 58. What's your interquartile range there? Well, that would be the 41 minus the 18, which is 23. Now let's take a look at Carl. The minimum score I have down as about a 6. The first quartile I have at about a 15. The median I had down at, I thought it was about a 32. You want to argue 31? Go ahead. Well, it's hard for me to tell. The third quartile I had at about a 47. And the maximum was 63. Based on the numbers that I have written down, what would the interquartile range be? Well, that's the third quartile minus the first quartile, which would be 32. And if I wanted the range overall, I would do max minus min, which in this case would be 57. All right, so that's a good summary of box plots. And again, it's the kind of thing where if you're teaching a class, or as a parent of a child, they often, and you take these national standardized tests as part of the Common Core. Don't get me started on that. They often send data to parents summarized in a box and whisker plot. And if you can't summarize the data or interpret the data, it's a disservice to your children. Most people that I know can't process a box and whisker plot. Okay, so now here's a histogram. Let's talk about some of the key features of a histogram. The left is always the frequency or the count. The bottom's the data or whatever intervals. So what I have going on here is this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. And the height of the bars tells you how many there are. Like it looks to me like this interval of 6 here, this looks like it has about 25 scores. Now, some of the things that are important is that all these intervals, these heights of this range here, they all have to go up by a consistent amount. 5, 10, 15, 20, 25. You don't see it like 0 to 5 and then this little tiny space 10, little tiny space 15, and then a jump all the way up to 20. They have to be evenly dispersed. And you should be able to, just like with a box plot, you should be able to interpret data from a histogram, as you are likely to see some histograms as well. Okay, so here's 3 questions based on a histogram, and I'm sure you've seen histograms before. So go ahead, try these 3, and we got 2 more histograms after this if they give you any hard time. Always stop and start. Okay, the mode is always going to be the tallest bar. So in this case, the mode is not 25, the mode is 6. It's the interval that's there. It just so happens there are 25 in this interval of 6. Which 2 intervals have the same frequency account? Pretty much the same frequency account. Maybe the 1st and 11th, that's a little tough to tell, but it seemed to me that the 4th and the 8th were spot on. But if you thought the 1st and the 11th, I can kind of see that. And what's the difference between the number who have 5 and the number who have 10? The frequency of 5 and the frequency of 10. So 5 looks to me like it has about 11. Oh, it should have been more like 15. I'm sorry. 5 looks to me like it has 15. And 10 looks to me like it had about 4. So 15 minus 4 is 11. Okay, some more questions here based on this histogram. This histogram has the number of employees that earn a particular salary. So for instance, in this interval here, that's employees who are compensated 20 to 30,000 in a year, and that would be just under 300 employees like that. So answer those 2 questions doing a stop and start. Go ahead. Okay. Now, find the salary mode. Well, the mode's always the tallest one, and that's between 40 and 50,000. Next, how many employees earn between 70 and 80,000? That's here, coming over to here, going straight across. Looks like maybe 350, 340. There you go. How many more employees make between 10 and 20,000 than make less than 10,000? Probably part-time employees. Okay, so that would be about 300 minus the 50, and that's 250. Okay, next part of histograms. And I'm sure you're doing stop and start. So how many in the class scored between 10 and 25? So between 10 and 25 means this column for 10 to 15, plus this column for 15 to 20, plus this column for 20 to 25. And that means I got about 20, about 25, and about 30. And if I add those up, I get 75. I spelled which wrong here. That's not a misspelling. My computer, the H is catching, and then the next time I use it, it'll do like 2 or 3 H's in a row. So I do know how to spell, all right? In which interval is the mode? Again, it's always the tallest interval. It's the green one here. So it's between 20 and 25. And how many in the class scored between 30 and 40? Okay, well, the blue one is 30, and that's about 10. And it's about 5 for the orange one at the end between 35 and 40. So 10 and 5 together make 15. All right. So we've been going over graphical representations of data so that you can interpret data as it's being presented to you. The last type that you might see is a stem and leaf plot. If you choose to be a teacher or if you choose to be a parent, your children will have this shown to you frequently, so you have to be able to answer it. I got to be honest with you. In my personal life, I don't know if I've ever had to use a stem and leaf plot. Histograms, absolutely. Box plots, absolutely. I can't remember stem and leaf plots ever being used. But they are very useful for organizing data. Show you how to do it. So here's a stem and leaf plot. And basically what they do is we have the data 10, 15, 22, 25, 28, 23, 29, 31, 36, 45, 48. And that is fairly in order. At least it goes 10s, then 20s, then 30s, then 40s. Imagine if like we put some 40s in the beginning and some 20s at the ends and some 10s and 15s in the middle and then sprinkle the 30s all throughout. It can be very difficult to see trends. So what a stem and leaf plot does is it organizes the data. And a stem is basically the grouping that starts it off until it breaks down into units, which are the leaves. So the stem here, I have 10, which I represent only as a 1, 20, which I represent only as a 2, 30 as a 3, and 40s as a 4. And then I just write the leaves, which are the unit digits. So it's 0 and 5, and then 2, 5, 8, 3, 9. And I always want to take the time to write those in order. Very important to write them in order. So I wrote 2, 3, 5, 8, 9. Same numbers. I just put them in the correct order. It's very important to do that because of questions like those we have on the right. For 30s, I have 31 and 36 represented with the leaves 1 and 6. And then for the 4s, I have 4, 5, and 4, 8 for 45 and 48. So how do you find the median? Well, it's the score in the middle. And I can count the scores. So this is just 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So if I have 11 scores, the 6th score is going to be the median because there's 2 groups of 5, right? There's 11 scores. So 2 go into 11 5 times. So you have a lower group of 5 and an upper group of 5. And then the 6th score breaks those 2 groups in half. So that's the one in the middle of the median. So here's 1, 2, 3, 4, 5. Here's my 6th score right here. My 6th score is not an 8. It's got to look back at the stem here, 28. So my median is 28. Now, with the numbers sorted like this, it's pretty easy to find the range. Range is just highest minus lowest. So it would be 48 minus 40, which is, 48 minus 20, because the stem is 1. So 48 minus 10, I don't know why I said 20. 48 minus 10, which is 38. I was just thinking about how tired I am too. And the mode, well, this is an odd one. There is no mode because no number repeats. find the first quartile and the third quartile. So we know that 8 represents the sixth score. So there's 5 below, 0, 5, 2, 3, 5. In that order, I'm leaving off the stem part. But that means the median of those is the one in the middle, which is the 2 here, right? 2 below, 2 above, then the median. So right here, 22 is going to be the first quartile. On the scores above, here's 1, 2, 3, 4, 5 above. The third one will be the median of those above. That's 36. So first quartile is 22, the third quartile is 36. And if I wanted the interquartile range, it would be 36 minus 22 is 14. So here's another stem and leaf plot for you. Go ahead, find those 4 values. Okay, so the median's the one in the middle. There are 1, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14 scores. That's 2 sets of 7, and there's no score in the middle because there's no remainder. So it'll be between the 7th and 8th score, the average. So 1, 4, 5, 6, 7, 8. So it'll be between 70 and 75. The middle number between 70 and 75 is 72.5. So that is the median. The range is the highest minus lowest, which would be 95 minus 41, which is 54. The mode is the most frequent or popular. This time I see 3 8s in a row. Bing, bing, bing. 8, 8, 8. So that tells me not 8, but 78. See, these are zeros, but they're not all the same. It's 70 and 80, 80. Okay, so 78 is the mode. And the first quartile, since we have a set of 7 down below, set of 7 would be 2 groups of 3, and then the fourth one's in the middle. 1, 2, 3. Here's my fourth one, 58 for the first quartile. And then likewise, count down 3 from the top. 1, 2, 3, 78 for the third quartile. Okay, the next thing we're going to ask you to do, the last thing we're going to ask you to do as far as this data interpretation, is to complete the stem and leaf plot based on this data right here. So you're going to write out the stems and then the leaves, and then we'll order them. Okay, so your stems are going to be 1, 4, 2, 3, 5. So basically 1 through 5. And there's my stems. Now, it's the way PowerPoint works. It's very difficult to put one number in at a time. So we can look through at all the ones, and there'll be a 7, a 5, and a 9. Then we can look through for the 2s. I'll see a 9, a 1, and that's it. For the 3s, 8 and 3. For the 4s, 3, 1, 4. And for the 5s, 0, 7, 3. Now we can't leave it like that, because then when we're trying to find quartiles and medians and stuff, things aren't in order, and we're likely to get the answers wrong. So we just rearrange the order. Again, the stems stay the same. The numbers stay the same for leaves, but rather than having 7, 5, 9, we're going to go 5, 7, 9. Rather than having 9, 1, we're going to go 1, 9. Numerical order here. 8, 3 becomes 3, 8. 3, 1, 4 becomes 1, 3, 4. And 0, 7, 3 becomes 0, 3, 7. And that is how you order your stem and leaf plots. The next thing we need to learn about is probability.